Hello, Ken Weller here with New Tech Inventors. Today we'll be testing a 625 volt amp UPS at our print farm and also experimenting with the 300 watt inverter. Let's see how these do. I've got this other Cyber Power 625 volt amp. I believe it's 375 watts. Now, it's doing a little beeping now because I have full heating on this Anet printer, and I've got this one, the bed and the head, fully heated, and we've just now gotten up to temperature on the third one. So basically we have 3 printers now fully heated and running off of this one 625 UPS. Okay, here we are again. Okay, we've got the 625 VA UPS hooked up to these 3 printers running, and now I'm going to pull the plug on the UPS and we'll see just how long we have here. Okay, we're running off UPS power now. Okay, it was about 10 seconds. So now let me preheat 2 of them. Leave that third one off. So now we're going to try it again. We've used some of the power in these batteries, so without giving them time to recharge, we're going to go ahead and try it one more time. Okay, we pulled the plug. We have 2 printers preheated. Okay, a little bit over 1 minute, about 1 minute and 4 or 5 seconds. So 2 printers off of one 625 VA with questionable batteries. Gave us just a little bit over a minute. Okay, we're doing a little testing here today. This is our 12 volt automotive battery. It is feeding power to this small, inexpensive 300 watt inverter, and from that inverter I have 2 printers hooked up to it, a Kingroon KP3 and this Creality Ender 3. Now what I'm going to do right now, I have the power on to the Ender, and we are supplying power to charge this battery from this power supply, and right now we're charging this battery with 14.3 volts, and it's drawing 1.2 amps approximately, and part of that power is going to keep this battery charged, and part of it's going to the inverter to power this Creality printer. Okay, now what we're going to do is preheat this printer, because this inverter is having to take this 12 volt DC and convert it to 110 volt AC for this printer. Okay, I'm preheating PLA. I'm preheating both the, preheating the Creality, trip the UPS. Give it a little more support power. Still charging voltage is good. And let's try our preheat again. Okay, we're up to 2.3 amps. We're still holding at 14.6 volts, mainly because we have help here. If I disconnect this, we aren't getting enough through these small wires. Start all over. Keep the battery in line. Now I want to I'm going to check a couple things here. Okay, I've just barely got 12 volts there. So let's see what happens when we preheat. Okay, we're preheating the bed over here. Our voltage dropped down to 10, so that means our battery is not very well charged, or these leads aren't large enough to carry enough current from the battery to supply the UPS. We should be at 10.9 volts. And that's why this guy's alarming. These wires are getting hot. I'm trying to supply the current. Summary is either this battery isn't very good, or I'm going to have to charge it up more and probably connect some larger wires carrying the current. Because it's getting more power from the power supply than it is from that. But the Kingroon is preheated. Nice hot bed. And you'll see the current kick up on this every once in a while. That will be when the Kingroon is there. The heat element just came on to maintain bed temperature. That's why the current picked up. So what this is telling me is that this little inexpensive 300 watt UPS will power the Kingroon printer with its 24-volt power supply. I'm going to get some heavier wiring to the battery, and heavier wire going to the power supply, so that they can carry a little more current and keep this temperature, this voltage. As you can see now, we're up around 11.6 volts. We should be, with the power supply connected, we should be closer to 12 volts or more. But that voltage will drop when that bed over there, right there, cut on, we're drawing more current, and our voltage dropped about 10 volts. So that tells me two things. One, definitely I need heavier wire to carry more current from the power supply to charge the battery and to maintain the power inverter. And I need larger wires from the battery to the inverter to carry enough current to handle the 300 watts. Because to get 300 watts at 12 volts, you're having to, you're looking at somewhere around 20, let's see, 20 amps, over 20 amps. And these can't really carry 20 amps that well. That's why we have the voltage drop. But I think this little inexpensive inverter, this inverter on eBay, including shipping, is $19.99 for 300 watts. I bought a couple of them just to see what they can or can't do. When I hooked it up to the Ender, let me cut off the Kingroon, and now I'll turn on the Ender. Now when I go to preheat the Ender, you'll see that that voltage will drop way down because it has a larger bed area, and the bed's going to draw more current. I'm preparing, and I'm preheating the PLA, and I'm going to go to the bed, and we'll watch our current and our voltage. Yeah, it dropped down way down there. I think it will power this Ender when I change the cables. So let's do that, then we'll get on with it. Okay, now we've added a couple more wires here so that we can handle a little more current going to our inverter. And again, this is a 300 watt inverter. Now I have this meter hooked up to read the voltage at the terminals on the inverter, and we are charging the battery. This is indicating our current and voltage going to the battery. We're drawing approximately a little bit, around 1 amp, a little bit more at times, at 13.6 volts. We're maintaining, you can see right now we're down to 1199, just under 12 volts. and then it drops down to 11.33. That is because we're having to maintain temperature on the head and bed of the Kingroon printer. And we're powering this 24 volt Kingroon power supply from the 300 watt inverter. So the inverter was able to handle the preheat of the Kingroon printer and maintain it. Now, if power is lost, the only power we have here is coming from the battery, and this is the only other power source we have. So if I disconnect this terminal here, we're no longer supplying power from our AC current to supplement this. It's all on that battery. And I'm not even putting a stopwatch on it because I believe that battery can run this inverter for a long time. And if you had several batteries, you could actually have one of these inverters for each printer. This inverter, as I said, costs $20, including shipping, on eBay. And you could have one for each printer. Now, in all fairness, if I were going to power the Kingroons, I would do it a little differently because the power supply is detached and it has this cable going to the Kingroon, supplying it with 24 volts DC. What I would do is get two 12 volt batteries in series, giving me 24 volts, and I would put that power directly in line with this so that if there was a power failure, I wouldn't have to rely on an inverter. I would just send 12 volts from my battery directly to the printers. And that would be very easy to do with the Kingroons. Now, with some of the other printers, like the Ender and the Anets and so forth, you have a little bit of problem with that because the power supplies are wired a little differently, and you'd have to actually go in and take the leads, attach to the leads of the power supply and do a few modifications there. But anyway, this is basically a test of this little guy here. I really think 300 watts, even though it'll run our Kingroon for a long time, especially using this larger battery, I'd be a little more comfortable if it had a little more wattage than this. I'd feel a little bit better with 400 or 500 watts. But 300 will get you by. Now, when I tried to fire up this Creality on it, it was a little bit too much for the 300 watts. And obviously it has a much larger bed here, which requires more current to heat this larger bed. So the larger your platform, the more power you're obviously going to have to maintain temperature on that surface. So that's a little bit about our experiment here, and this will help us come up with a plan for the print farm and potentially an economical backup source.